to deal with the topic of polyatomic ions. The first learning target is just to know the 8 most common polyatomic ions. So what is a polyatomic ion? Well, if you look at the name, polyatomic ion, poly means many, and atomic obviously refers to the atom. So this is a many atom ion. You're used to seeing ions like sodium ion or the chlorine ion, where the sodium ion loses an electron to become +1, or the chlorine ion gains an electron, becomes a -1. Instead, these are groups of atoms that gain or lose potentially multiple electrons to become an overall group of charged atoms. Okay? These atoms are all covalently bonded to one another, but they have extra electrons, or they've lost electrons. Okay? So they, as a group, serve as a single ion. We often like to think of these as, this is silly, but 8th grade girls, okay? This group of atoms goes everywhere together. Okay, they go to the bathroom together, they go talk to teachers together, they go to the movies together, they literally do everything together. Polyatomic ions are like little groups that are charged overall. Okay. They're going to end in 8 or ite. Generally, there's a couple exceptions, but if you see so far, our ions are either the name or they end in "ide." So the way you'll determine or differentiate between these and periodic table ions is that they're going to end in 8 or ite. 3 exceptions: hydroxide, ammonium, and cyanide, which you just have to memorize. Okay. So what are the 8 that you need to know? This document is already on the Moodle. Okay, so you have to memorize the following polyatomics. You need to know the name, the symbol, and the charge. So those are your 8: sulfate, phosphate, carbonate, nitrate, chlorate, ammonium, acetate, and hydroxide. Those 8 will be quizzed later this week. Okay? But those are not the only polyatomic ions we see. If you look down here, there are some rules that from the 8 you memorize that will allow you to produce even more polyatomic ions. So if you take the number of oxygens within the polyatomic ion and take 1 away from it, then it's going to become an ite. So phosphite, sulfite, nitrite, and instead of phosphate, sulfate, nitrate. And if you look at the difference in formulas, the charge is the same. The only difference is the ites have 1 less oxygen. Okay. Well, what if you have 1 more oxygen? 1 more oxygen is called per, and then whatever the name is. So like perchlorate will have 1 more oxygen. Persulfate would have 1 more oxygen. If you have 2 less oxygens, that's right here, that's the hypo something ite. So like hypochlorite, hyponitrite, hypophosphite is 2 less oxygens than normal. So from our 8, we can do 1 less oxygen, 2 less oxygens, or 1 more oxygen and generate even more potential polyatomic ions. Okay? The ones I have on this list are the ones you're going to most commonly see. I wanted you to be familiar with them. You're not going to see lots of hypos. You're going to see hypochlorite and maybe hypophosphite. You won't really see hyponitrite or anything like that. So that's why I had them on this list. In all of these cases, you can see that the charge on the polyatomic ion stays the same. Whether you take away an oxygen or add an oxygen, the charge will be consistent. If you change the charge, the way we do that is by adding a hydrogen. Okay? If you see a polyatomic ion with a hydrogen in front of it, the charge will be reduced by 1, and the name will simply include the term hydrogen in front of the name. So like hydrogen carbonate has a hydrogen in front of carbonate, and carbonate's charge goes from 2- to 1-. Hydrogen sulfate is an H in front of sulfate and goes from 2- to 1-. Okay, so you can kind of see the pattern here. On the board, I have what polyatomic ions actually look like as a reminder. Okay, they are covalently bonded to one another. You can see here they're sharing electrons, but they have a charge. And that means they can come together with other ions, right, to become overall neutral. This case, if you wanted to bond it with sodium, would be Na2SO4, because SO4 has a minus charge and sodium has a plus charge. Okay? Now, what happens if I need multiple polyatomic ions? let's say, for example, if this was bonding with aluminum, one of our hardest cases, if you're bonding with something where you need more polyatomic ions to make this balanced or neutral, the aluminum, you'll put your subscript below just like normal, but for the polyatomic ion, SO4, in order to indicate we need 3 of them, you're going to bracket the polyatomic ion and put the 3 on the outside. This now says, hey, everything inside that bracket, I need 3 of. Without the bracket, it looks silly, okay, because you have SO43, which doesn't make sense, SO43. And with the bracket now, we know specifically which ones we're multiplying. So here's a couple more examples we can do. So the first one we'll do is sodium phosphite. Sodium is Na and has a charge of +1. Phosphite, okay, these are the ones, some of the ones you had to memorize. This is phosphate. The ites have 1 less oxygen, so phosphite will be PO3 minus 3. Okay. To put these together, we need to have them come together to become neutral. So you need the correct number of ions to make the overall charge of 0. In which case, to make this neutral, you need 3 sodiums and 1 phosphite. Calcium chlorate. Chlorate is one that you have to memorize, which is ClO4 minus 1. Calcium on your periodic table has a charge of +2. To have these come together to become neutral, you need 1 calcium and 2 chlorates, which means you want to put it in a bracket to indicate this whole thing happens twice. Okay. The next one we're going to do is going from formula to name. So that's MgNO3 2. This is magnesium. This right here is a memorized one of nitrate. And the only other question is, does this need a Roman numeral? Well, is it a transition metal? No, so no Roman numeral. That is your name. Next one is this one, FeHSO4 2. This is iron. This is hydrogen, because there's a hydrogen on it. SO4 is sulfate. Okay. You do need a Roman numeral because this is a transition metal. To determine what that Roman numeral is, you need to figure out how this ends up neutralizing itself. So, what is a charge on hydrogen sulfate? Sulfate is normally 2-, which means with the hydrogen, it is a -1. You have 2 of them with -1, so this must be a charge of +2. Because +2 and 2 -1s is going to add up to then be 0. Okay? That's your tutorial on polyatomic ions.